models. Right, guys, maybe we should start because people are waiting. Yeah. Yeah.
Okay, let's yeah.
You kick it off.
I kick it off. Welcome everyone to today's session of the hot and spicy. The hot and spicy is something we do on the first Friday of every week. I think I say that correctly.
First Friday of every week.
Yeah. First Friday of every month, and it's the idea is that someone gives an impromptu presentation. So that means they get at most 2 hours to prepare, and it's supposed to be about something that's new or interesting in some way. So today's presentation is about large language model prompting, and Mansoor will be presenting. So Mansoor, take it away.
Thank you. Yeah, this is my first hot and spicy, and indeed, I've been preparing only for 2 hours.
That's very good.
We noticed.
Yes.
87 slides.
Yeah.
Did you start recording?
Yeah,
Yes,
I think
it's recording. Yeah.
Okay. So today's topic is about large language model prompting, and how do models like ChatGPT work, and how can you use that knowledge in further work with GPT-like models. So first of all, let's start off with just a contents overview. So I'm going to talk a little bit about how do you train classical machine learning models in certain tasks. Then I'll explain what zero-shot learning is, what does GPT stand for, and where do you look after. So let's look at classical ML, or more specifically, deep learning. How do you approach a task when you want to do a deep learning? For example, if you want to do like a image classification or image recognition, you would usually take a pre-trained model, for example, pre-trained on ImageNet, and then you would copy that model, and for example, you want to train it for a shoe classification task. You would take the model itself that it was trained on ImageNet, for example, and then remove the last layer, and then add a new one to replace it. And then you only train the last layer of the neural network. And the idea behind that is that the features that you get in the first few layers are actually so generalizable that you could technically train the neural network to see those features, and based on those, figure out what is in the image. And this method is called transfer learning. So technically, you could perform transfer learning not only on image classification, but you could also fine-tune models like BERT, for example, for understanding text, classifying text, doing some semantic analysis. You could also fine-tune YOLO models. For example, you could do that for object detection, and that is quite helpful. You could also fine-tune models, for example, for voice classification, or a very interesting example is like OpenAI's gem. So you could technically train something in a virtual simulation. For example, this arm that is trying to solve the Rubik's Cube, it's running like thousands of simulations at the same time. And then when they want to actually deploy the model to the real world, what they do is they use the real hand and fine-tune the model in the real world. So there are many very different applications for fine-tuning, and they work pretty nice. And it is nice. However, it has some drawbacks, and the main ones are you really need huge data sets to actually train the models. Maybe for fine-tuning you need less big models, but they still have to be big. And at the same time, you also need a lot of compute power. So if you want to fine-tune BERT, that's a lot. Just to run the model and to fine-tune it, it's a lot also. And yeah, and most of companies, most of people, individuals don't have access to such and such resources. However, they still can do something, and that something is called zero-shot learning. It's a more or less recent thing that came out. To explain what zero-shot learning is, I think it's really nice to look at an example. So this is an example from Hugging Face to describe what zero-shot learning is. So here I have a description of well, what Researchable is and like what we stand for. And then I just added 3 or 4 classes for like research, education, transport, and software. And somehow this model, well, it wasn't really trained on classifying into 4 classes, but it is able to, just based on the text, somehow figure out that probably Researchable would go into research more and more software, but not into like transport or education. And that is what zero shot learning is. So you don't have to train the model. There's no training going on. It's you use the inherent knowledge that is in the model to generalize it to other new tasks. Another example would be review classification. So this is a review of Interstellar. It's a very not positive review, and I gave it 2 classes, positive and negative. And somehow the model just figured out that this goes into the negative class and not the positive, with very precise and high confidence. So we're gonna look specifically into zero-shot learning in natural language processing. So we're gonna more talk about GPT. However, there are still applications for zero-shot learning outside of natural language processing. For example, there are models such as CLIP by OpenAI, which are able to take images and somehow connect them with text and put them like into one latent space, which allows you to classify images, write image descriptions, and you don't really need to do any training on that also. It's just a huge model that was trained and it works. And it's very generalizable. So before we start actually talking about applications of GPT, let's figure out what does GPT stand for, what does it mean? So GPT is an acronym for Generative Pre-trained Transformer. And well, maybe those words don't mean anything, but the transformer is an architecture that is used in the neural network model or the deep neural network model. Pre-trained means that the transformer was already trained beforehand. That's why where it has knowledge that it can use to do its tasks. And finally, it's a generative one. So that means that it can generate new content. It creates new content, something in that sphere. So now, before we continue, I'd like maybe, I don't know, if somebody wants to share, what do you think, like, how would you define like GPTs, like for yourself? Like, I mean, I know you know what ChatGPT is, you know what GPT-3, GPT-4 are, but like, what are your views on like, how would you describe it into maybe 1 or 2 sentences?
It's like language-based prediction model, right? So you give it some text and then it predicts, oh, this is what I expect will be the next word or the next sentence or how the thing will run. That at least was my impression of the whole ChatGPT.
Okay.
Probably wrong, but
it isn't. There is no right or wrong answer.
no, that's
like,
probably it.
I would probably ask ChatGPT to come up with an answer for this. It's
Good
an
point.
autocomplete, right?
Autocompleter. Okay. So we can see there's like an underlying thread of like what is common between those definitions, and that like the GPT model, it generates based on something that was given, so it autocompletes, it predicts the next word, it tries to fill in whatever it based on whatever it had before. So that's like the general idea that people usually have when they think about GPTs, ChatGPTs, and stuff like that. But let's go on into more like technical terms, what it means, and maybe look at the architecture a little. We'll not really go in depth, but we'll cover some of it so that you get a general overview of how it works. So first of all, we're going to look at the attention mechanism. So the attention mechanism is like the essential module of the transformer architecture. Basically, what it looks like a weird diagram, but it's a very simple model. So what it is actually like 3 neural network models. So you have a green part, which is like the input to the attention layer. So it is like an embedding. It is, for example, some vector, some matrix that represents the data that is inputted. So for example, it could be like a matrix of text or something. And then, so that matrix is passed through a neural network model, which is like basically just matrix multiplication, to generate a query. Then it's passed to another one, which generates a key, and then it's passed to another one, which generates a value. And well, we just assume that the query and the key, if you multiply them together, you scale it somehow, and you apply softmax, which basically makes it 0 or 1. You will get a matrix that is telling you the probability that you have to attend at something. So like pay attention to something at a certain moment in time. And then the value is just, well, it looks at, okay, we are paying attention, but also like what a value do we assign to that? And so that is multiplied, and we get with one attention layer, one attention head. So that's how it's called. And if you want to look more into that, I've attached a video link to an MIT lecture. Okay, so let's look into it more like on an example way. So imagine we have a machine translation task, which is translating from English to French. So you can see that if you look at the sentence that is shifted horizontally, which is the English one, and then look at the French one, you're going to see that there are like patterns which are like white sparks, sort of. And the brighter the spark, basically the higher the value of attention, which in itself means that the model is paying attention to something when it's looking at something else. And well, I don't really know French, and I cannot really read that, but you can see that it's not just purely diagonal. So you can see that something is coming beforehand, or like something is like shifted, like especially the like 3 diagonal, which is going the other way around. Mm-hmm. So that you can see that the order, for example, it can shift the words around, and itself it can generate basically the translation. And yeah, that's more or less how the attention mechanism works. Now I want to go more into like where did the transformers come from, and I think it was introduced by Google in their paper called "Attention is All You Need." It's a very famous paper that like everyone, if they want to do like transformer stuff, has to read or has to know. And there they introduce a transformer architecture which looks like this. It's basically a bunch of attention models on top of one another, and then you also have like self-attention, which is, well, the thing that we saw with the value and key and query. And then there was also like multi-head attention, which is like a bunch of attention heads connected to each other. And well, more or less the transformer architecture looks like this. It has changed a little bit throughout the years, but that's it. And the power of the transformer architecture is that it's a general differentiable computer. So it has the ability of something like a computer, and at the same time, it's differentiable. So it can perform, you can perform learning on top of it, basically. Let's look at one of the first models which actually was released. It's GPT-2. This is the API hosted on Hugging Face again. And well, we know that already the generative pre-trained transformer, its task is to actually predict the next word. So what is going to happen is like we're going to submit the description, which is like cut midway, and then ask the GPT model to generate the following tokens, and which we will do, and it will generate some response. And maybe it will not be the best response you would ever hope for. However,
existing. Okay.
Yeah, existing, or new technologies from design and execution of the social impact. Responsive technologies offer a global solution to deliver, and oh yeah, I didn't really finish, but it is something. It looks legit. It looks like something that maybe it looks at least human-like. That like a human maybe have written it, but without any idea in their head. And the funny thing is about the transformers is that, well, this is GPT-2, and then you have GPT-3, and yeah, those are the two papers. And the only difference between GPT-2 and GPT-3 is that, well, GPT-3 is more shallow. It maybe has sparse connections, and it's just bigger. And the fact that it can generate text, which, for example, if you ask ChatGPT, it will probably do better, is just because it's a bigger model and it has a emergent behavior just from predicting the next word, the next token. It can have almost like conscious-like behavior. I would probably assume you've already worked with ChatGPT or like at least seen the examples of what it can do. And it's just amazing, right? Like it seems like it can understand everything that you write and then from that do whatever it has to do next. Now I want to go into the GPT-3 paper, which is called The Language Models Are Future Learners. So this talks more about the GPT model itself, or more like about its behaviors rather than the architecture, because architecture is very simple. Like you don't even need to like copy code from anywhere. You just literally write, okay, I need a GPT model with this many layers, this many heads, with this many attention layers, and well, that you can just find in the paper. It's super easy to replicate. However, what is hard to replicate is actually to train the model, to fine-tune the model, to get the data that you need to actually make it so smart. That's why most of the GPT models were made by like huge corporations. So in Russia, it would be banks and like huge tech corporations. In US, it would be Facebook, it would be OpenAI, it would be Microsoft. Google has their own models, which are, well, not well, but still are nice.
But what did OpenAI? What data sources did they use to train their model on?
So as far as I know, OpenAI trained their models on just internet connected data. So it would be Wikipedia, like, so they would have all the information from Wikipedia. It may be some news articles. They would maybe scrape some data from the internet so that it has knowledge of like HTML or stuff like that. They would also use GitHub as a also main source of code, so that their model could just predict the next token in code. And in that way, for some reason, somehow, just based on the data, the code, the news, the articles, it would gain the ability to actually follow tasks and stuff like that.
But that means that now with the access to the internet, you don't need to be a corporate. You need a lot of money and resources and good people, smart people, but you don't need to have your own data, right? You can just use the internet. Like you mentioned, Microsoft, the big Russian banks and big companies, they are able to pull this off because they have a lot of data.
Yeah.
But OpenAI is just using open data.
Yes, exactly.
Also, they have a lot of money to run the supercomputers.
Yes.
Yeah. Okay.
So just to put it into perspective, I think they were training the GPT model for at least a month, nonstop, on very high performant, a lot of like huge clusters of GPUs. And the funny thing is that like the GPT training set had also like a leakage. So it's like when you train a model, usually in machine learning, you have like a training set and a test set. And so, well, like the model is not allowed to peek into the test set, it's just training on the training one, and then you test it on the test one. But they had a leakage between them, so they had some examples that the model was trained on, but they didn't want to retrain the whole model again just to get the results better. So they just went with that. And yeah, here's the paper. So
I think it costs like €500,000 euros, right? To train
costs a
them.
lot.
I think even more. Okay,
Yeah.
that's what I read.
I'm not sure if you can see the examples, but this goes into how you can train technically the language model with like meta learning, or how we call it now, prompt learning, or few shot learning. On the slide, you can see that there are a few examples, which 5 plus 8 is 13, 7 plus 2 is 9, 1 plus 0 is 1. And then they're given, the GPT model is given an example, 3 plus 4 equals, and it's just given a task to fulfill like what comes next. And it will somehow figure out that it's actually 7. And then if you continue on, you get more examples. And then the model just somehow magically begins to perform better. And well, that's very interesting behavior. Let's look at the second column. I don't think people here can see, but this column represents examples where the GPT model has to autocorrect the errors in the words. So for example, there's the word gaot, which spelled miscorrectly has to be goat. There's a sakne, which has to be snake, brid, bird, and so on. Yeah, I cannot even read that. So there are examples like that. Let's imagine we give the first example. We just say gaot, and then the equals arrow, and then expect it to output something. Well, the model, it will perform very bad. And that is the zero-shot learning, because like it has no idea what it has to do. But then if you give it the example goat, and then you ask it the next thing, so it's sakne, and then the arrow thing. Model maybe will guess it's snake, maybe it will guess something else. But then with the more examples you give it, the model will be able to understand, oh, okay. Well, it actually doesn't say that or doesn't do that, but somehow it figures out that there's a pattern which has to follow. So it's say the correct word, say the correct spelling. And if you think about it, it makes sense, right? Because like we as humans, we also work from examples. We do have some general knowledge, but then we encounter some new problem. We see a few examples, and then based on those examples, we figure out, okay, I have to do this, I have to do that. This is how I tackle this. This is how I tackle that. And this is what few-shot learning is about. So you give it multiple examples, and based on those examples, the model is able to figure out what comes next. The last column represents machine translation from English to French, I think. So it's thanks, merci, hello, bonjour, minte, wall, and then we'll figure out this mur. Bread is pain, apparently. So yeah. And
to get bread, you need to work, and work is pain.
Yes, we'll have to ask French people about that.
They protest a lot for this, so it's true.
So let's go more into the detail of like the beauty of shot learning. Well, I talked about zero-shot learning, the one-shot learning, and few-shot learning is just based on a few examples. And maybe sometimes you could even give it a task description. So you could say, okay, translate from English to French, and then you give cheese and then the arrow thing, and it's a prompt. And then, well, it will try to predict the next token, and it will figure out, okay, cheese is, I don't know actually how to say cheese in French, but
Fromage.
fromage.
Yeah.
So then if you give it maybe one example, which is like C auto translate to whatever that is, I'm sorry, then it will maybe perform better. And then if you give it like 3 examples, like a few examples, it will perform even better. And the cool thing is about that is like nowhere in this schema we actually perform any gradient learning. So by gradient learning, I'm referring back to the initial example of classical deep learning, where we actually had to train the model, to fine-tune the model, to update its gradients, update its weights. Here, we're not updating the model. We're using exactly the same model as it was when we trained it initially. And this is the most powerful ability of the GPT and other models like it, is that like you don't have to do any training. You just give it examples and it figures it out. And on the side, you can see the example of how you would do gradient updates. So let's come back to like how do you do fine tuning. You give it an example, it performs good or bad, then you update the gradients of the model. So you literally punish it and update its weights, or reward it and update its weights. And you continue on doing that and that until it actually gets better at performing such tasks. And also another interesting thing is that I think there was done research into that, is like if you have a general model and if you have a specifically fine-tuned model, the general model would perform better overall on some task that the other model was trained on. So, for example, if a model is trained on summarizing that task, and then you compare it with just a general model which you tell to summarize the task, most likely the general model would perform better than the smaller model which has been specifically trained to summarize text. And I think that's very interesting behavior that you can think about.
Do you know if the task description, which sort of appeared in this slide, it wasn't there in the previous slides, but is this something that they specifically implemented in the architecture of the model, or is this like where did this come from?
Okay, so the task description, it's not part of the model itself. It's actually part of the input. So, well, we know that the GPT models are next word predictors or next token predictors. So the model itself, it can see the context. So it can see the text that was written beforehand. And based on that, it will just predict the next token. So it's not something you embed inside the model itself. It's just you tell it to literally, like you just put the example as text into the input also.
So you could technically, you could technically write a prompt that says translate this text in English to French.
I can go. Right?
Okay.
You'll never know.
Yeah, we'll never know what's going on.
No. You can autocomplete it.
Yes.
Sorry. I'll complete my sentence exactly. So, like, what would happen if you took the description of the task, and then you tell it to autocomplete without actually giving what it has to, like, translate the following text to English, and then you don't give text.
Oh, okay.
You know.
Yeah, then it will probably, in the jargon term, hallucinate whatever comes next. So probably it will come up with some English text, and then it will come up with a translation to that English text. Yeah, that's what I would expect. We can also test that after.
Let's test that. Yeah.
I have actually the models prepared, all sorts and varieties you can think of. But yeah, we'll come to that a little later. So let's look at the performance of the models. So with different colors, you can see the blue one is the GPT-3 model everyone is talking about. And it's the biggest model. So it's, I think, the Da Vinci one. It has 175 billion parameters. That's a lot.
That's really low.
Then,
what actually is a single parameter?
So a single parameter would be like a weight in the neural network model.
Okay.
Then we would have the next one, orange one, coming is 13 billion parameters, and the smallest, I think it's called, I don't remember how it's called, but it's 1.3 billion parameters. It's the cheapest one you can have on the OpenAI API. So as we can see that if you have a bunch of parameters, it plays a huge role in terms of improving the model. But what has a bigger role is the number of examples in the context. So that's the x-axis. So the more examples we give to the model, so for example, we can see the zero-shot learning is like in the beginning, it performs like on average like 10% correct. But then if we increase it, like give it at least one example, it already jumps to like almost 50%. That's really cool. And then if you add more and more examples, for example, by 10 examples, you will reach an accuracy of 60%. And from that point, I hope it grows.
Is there also a trade-off here? So let's say I have a model with 1,000 billion parameters. I'm not sure how we call it.
Yeah.
Would I need like a bigger inputs, like set
Context size.
Yeah, a bigger context size.
No, I think well, each model when
looks like that in the graph, kind of a bit. Maybe.
So in general, GPT models they have like a fixed context size, and well, that's something you specify when you want to train the model. I think in the recent OpenAI model is like 8,000 tokens in the context. So a token is like you could imagine it's like a syllable, I think. So this is like how many words you can technically input in the model, and that's how much tokens it can look back to also. So, but yeah, I think the context size, well, it does play a huge role in the number of parameters because like
Kom ik wel.
Alsjeblieft. Alsjeblieft. Laat ik daar.
Hey,
Dankjewel.
Ja, de tas was
right.
kapot.
Yeah, so the context size, well, it can be manipulated, but usually it's more or less fixed. I think it's 512 tokens, but I'm not sure. Yeah. So I want to look now at an example that they provide in the paper, especially in the like reasoning sort of examples. So where you have to actually think. So Lambada is a task where you have to think and like kind of interpret. Okay, this is like the context I have, and then from that you kind of determine what comes next. Or so, for example, Alice was friends with Bob. Alice went to visit her friend, and well, the model assumes that well, probably they're friends. That was mentioned. Then it figures out that it's Bob, and the same goes for the next example. So George bought some baseball equipment. He bought a ball, a glove, and then like we as humans can naturally figure out that it's a bat because like how do you play baseball with the bat without the bat? So that would probably be the response of the model. And well, the paper suggests that the GPT-3 model achieves an accuracy of around 86% in the few shot learning setting. And well, it's a 18% increase from the previous state-of-art models, which is a lot at that moment when the paper was published. Just to compare, we can see that the zero-shot SOTA is basically the models that were just told, okay, do this task. They performed around like 70% accuracy. We can see the humans, they're around 95, I would think. And then just by increasing the number of parameters in the model and by increasing the number of examples the model has, it performs better and better, and maybe even like quite close to human level performance on this task. So it's, you can achieve almost 90% accuracy, which is amazing.
What is LM?
Where?
Parameters in LM.
Language model.
Oh yeah, of course.
So here I want to look at an example that I was playing around this morning. And it's also a very famous example in like
Word2Vec.
Yeah. Word2Vec, exactly. So just for some context, there was a model which was called Word2Vec, and it could basically embed words into some latent space, and then from that you could perform literally vector or linear algebra on top of those vectors. And one cool thing that you would see is that you could take a vector of king, and you could take a vector that corresponds to man, subtract one from another, add a woman to that, and you would get a vector that is very close to the vector queen. And that is like a also fascinating thing that you could see from the models. But this model, it doesn't work like that at all. It works based on context, so it doesn't do any vector algebra like that. It just tries to predict the next word. So when I inputted it, it predicted the king and queen. And I'm like, okay, maybe if I steer it, like it didn't really have any examples, and I didn't tell it like to what to perform. It just figured out it's a king and queen, whatever that means.
So this is the zero shot.
This is the zero shot example, exactly. So then I put that to queen, and then I gave it another example. So iOS minus Apple plus Google, that would be Android. So it's like the operating system, I guess, example. And I didn't say it was Android. The model, like the green part, it actually predicted that on its own. And then I left it as an example and gave it the next one, which was like, you remove the human from the brain and you add the robot.
Rule
That-
domination.
Yes.
Yes.
They know.
They know.
And that it will achieve artificial intelligence. This is like super nice. Like I didn't even think that would be the response, but indeed there is. It is. And I wanted to get something like in terms of frameworks, so I would remove deep learning from TensorFlow and add front end, and I suspect something like React or Next.js or something like that, that it would return full stack or just front end.
What is TensorFlow without people?
Yeah, what did you expect?
Yeah.
So TensorFlow is a framework for deep learning. So I would say it's like things like a framework for deep learning minus deep learning is a framework, and then your framework plus front end, it will be framework for front end. So it's
Yeah.
React.
deep.
But I think if you maybe would do that with Word2Vec, maybe it would have been better. But still, this is quite amazing. So
There's pizza, by the way, if anyone wants to grab this slide.
let's look into why is it important to know how the GPT model works. And here I mean, like how I mean that not the architecture itself, not the how the matrix multiplication happens, not the attention mechanism, not anything like that. I'm focusing specifically on how the GPT model, it looks at the context, how it interprets the context, and based on few examples, maybe 0 examples, maybe few examples, it can predict what will be next. And that's the main thing I suggest you to remember, is that based on the context, that it defines basically everything how the GPT model will perform after. And well, this is very apparent with ChatGPT. If you work with it, it is very apparent. Well, it's highly apparent when you work with the GPT models themselves, because like the ChatGPT model, it was trained specifically for like to be like a chat version.
Yeah.
But if you work with like just normal GPT models, they would be like maybe having a harder time to actually process, oh, what is my purpose? So giving it the purpose, giving it the meaning, the context, it's very important in defining how the model will perform. So now I want to maybe look at some examples that OpenAI provided when they released their GPT-3 model. And I think it grew since the last time I looked at it. But you can see, oh, it's laggy, but you can see that there is machine translation from Python to natural language, tweet classifier, science fiction book list maker, third-person converter, essay outlines, summarization, creating study notes, restaurant review creator. So there are just many applications where you could actually use the pre-trained transformers. And yeah, so let's look into one of them. For example, the product name generator. How the prompt would look like is you give it a product description and say there's like a home milkshake maker, then like seed words. So it's like I don't really know what seed word means, but I would assume it implies that it's like use these words to generate the product description or product name or something like that, like stem from that. And then we give it an example of like what product names it could be. So it's like home shaker, fit shaker, quick shake, shake maker. And then when we give it a real example that we want to get the output of, we say product description, this and that. I want that can fit my shoe size. The seed words are adaptable, fit, omni-fit. And then on the bottom, you can see the product names that it comes with. So adapt fit, omni secure, fit all, adapt shoes, which is very representative of the example that was given. It uses the seed words, and it is just based on a next word predictor. The same thing could go for the movie to image, movie to emoji generator. So you can see it, you have some examples. In this case, you would need a little more maybe. So we have Back to the Future, which is like a young guy, a grandpa, a car, and a time clock. Then you have Batman, which is like a gentleman with a bat. Transformers would be like cars and robots. And then for Star Wars, it generates stars with a sort of nice cross, sort of. So I would assume it's like stars and like laser swords just hitting, something like that. So yeah, this is I think a ground on which you can begin thinking maybe where I could use this technology, where we could apply it. And even like before ChatGPT, there were already models and there were already companies which are trying to replicate the success of the GPT models or try to utilize these GPT models. Very famous examples I used when I was in high school were like Quillbot, which takes any text and then it's like paraphrases into another text. There were examples like Grammarly. Grammarly actually uses a GPT-2 model, which was fine-tuned by themselves, but it's still a amazing thing that like they use GPT models. There were companies such as Text AI, which I worked for like one day. Yeah, where to look next? Let's go. So the company, oh wait, we'll go to that later. So the Text AI, their goal was to actually generate product descriptions so that you don't have to write them on your own. And when I was working for it for one day, I had to basically fine-tune a GPT model so that it could generate product descriptions. But what we figured out is that if you fine-tune the model, it actually performs worse than if you have the general GPT-3 model. So they stick with the GPT-3 model. And I'm not,
you got yourself unemployed in one day because you figured that out.
yes. Well, that was my
You automated yourself basically. Wow.
It was an interesting experience. I think it's like my first introduction to like GPT models at that time. I really was excited to do that also.
Don't you think that Grammarly, it was the first tool, maybe, well, one of the first that really had the impact on a global scale with well, correcting your sentences and these things,
Yeah,
which is quite new. But now with OpenAI, everyone can start the new Grammarly basically because of the API.
yeah.
But don't you think all those other, they put so much effort in it, and so why would you use Grammarly now, right?
True, but I would still think that Grammarly is much better because, well, Grammarly's service, the
application
product,
around it.
yes, it is much more than just the model itself.
Yeah.
Because like they suggest, first of all, multiple styles that you could write in. So like you could maybe paraphrase some words into like more formal world or more like chill or study or academic.
Yeah.
Their whole service is very well made and well defined, and it cannot be just replaced with a raw GPT model, I think. Yeah. Although I think maybe at some point it will be, but I'm not sure if we're that close to such level of intelligence from the GPT models. Another example I want to go over is also Centella. It is a recent company that was co-founded by one of the viewers right now. It's Mo. So Centella, as far as I understand, it's a model that it's a plugin that you can add to Chrome or any browser actually, and then you select any text and you can give it multiple tasks with which it can do. So for example, it can summarize text, it can explain it to like a child, so it can do a lot of stuff that you would technically use ChatGPT for, but then it's very handy that it's basically under your hand, with a plugin that is easily accessible. And the thing is also free, so you can feel free to try it out. And it works quite nicely. I use it for example, when I read articles, or like when I'm lazy to read articles, I just summarize the articles and hope that it's the gist of the article, and it works pretty nice, I think.
Is it a Chrome extension?
Yeah, indeed. Yeah, it's free, and you can use it.
And Mo is from Groningen, right? He studies here.
Yeah, he's studying here.
Studies.
Yeah.
Nice. Really cool.
So I've seen like lots of plugins lately, even like VS Code plugins or Vim extensions or browser extensions that simply make an API call to OpenAI, and they give their own prompt, and then they give it all the context that you see. Is this like that?
Like,
or is it
pretend you're a helpful AI?
Yeah, exactly. It's
Yeah.
the whole idea is just that the developer creates a prompt, like 2 lines of humor text, and then pastes other text.
The innovation is already there, but then to expose it indeed, or bring real value to certain context, that's new. That's not something OpenAI is doing.
Yeah,
it's also a very non-trivial task. So, for example, code completion, it's a very novel and interesting topic that everyone is literally exploring, because, like, well, you can automate your programmers now, or at least make them faster. And it poses also a few interesting questions. And indeed, I think it works, or like, I know if I can give 2 examples. So Copilot, it literally generates it throws the code inside the model and maybe gives it some context. So it copies some code from your other files, and then it tries to predict what's the next code is going to be. And like, if you put some comments also, that will just help to guide the model, basically. Some people, well, they could use just the normal GPT-3 model. They could put the code inside and then like tell, oh, okay, could you please autocomplete this code? And more or less, maybe it will work. I'm not sure about the performance, but it can do that. I've been also looking into how JetBrains does it, and it's a very interesting application because, well, first of all, yeah, I think I can talk about it. They want to train their own models. So, for example, for very specific and narrow tasks, because, well, JetGPT, it's very Copilot. Copilot is very nice. However, it has trouble in actually in certain specific or very rare cases where you have to write some cumbersome or hard code and where you have to actually think. In those places, it makes like minor mistakes or just makes mistakes in general, which are very not good. So what JetBrains plans to do is actually classify whenever, like, what type of autocomplete do you want? And so they have like 3 or 4 models which perform different types of autocomplete for Python, for example. And maybe they'll try to generalize that. But then also, I think there is research going on into actually personalized code generation or text generation. So it's very similar to adding the context to the model, but the context itself, it's not as text, not as something like that. It's actually like literally weights that you add to the model, and those are like specific to you weights. And then those weights, they encode maybe like your, I don't know, your coding style, or like the way you type, or like the way you comment, and all of that is encoded into that like table or a matrix, and then you just pass it to the model also, and based on this information, it can generate code that is very similar to yours. Yeah, I hope this answers your question.
Yeah.
So the last weeks I uploaded all the sensitive data we have in Researchable in the models. What do you think of companies doing all just using these services and feeding the models of OpenAI with their data?
Well, I think it's maybe not safe, maybe safe. I don't know. Like, I don't think they will use it for anything malicious or anything. However, it is very an ethical question, because like now OpenAI literally has access or can get access to a lot of code bases.
Yeah.
Using Copilot, they can get access to just like literally recently on LinkedIn, I read a post from some company.
Samsung.
Yeah, you like the comment.
Yeah. They uploaded their private information. The researchers uploaded private information on the projects, and then now it's in the OpenAI database. And well, they cannot do anything about it because in the policy they say, "Oh yeah, we're going to use the data to train the models and blah blah blah."
So
So
if you use the right prompts, you can get their secrets. Maybe.
yeah, no, okay, maybe at some point. Because like if it's trained on that, maybe it has the example somewhere in its memory, and then
Yeah.
somehow you can trigger those. So it's a very
Ethical.
thin string that you can walk on.
Yeah.
But I think it's very revolutionary, and I think it can bring a lot of benefit to humanity. Well, it is already, I think. I hope. I find it helpful, at least. One thing I want to also talk about is ChatGPT plugins. It's a very recent update. And well, what we know about the GPT models is that they're very limited in terms of their knowledge. So they can know something till the point that was in their data set. So till like September 2021 or something like that. And they don't know anything else about later. And one way that OpenAI is going around it, and I think it's very smart, it's actually adding plugins to the chatbot itself. So now ChatGPT, it can use other APIs and it can actually access them. And for example, you could give it, okay, I want a meal plan, which has all the data of like the protein and servings and stuff like that. And I want it to be generated, but then I also wanted it to be like in a shopping cart list so that I could go to the shop and actually buy the appropriate amount of groceries. So what it will do, it will use one API, I think Instacart. Instacart orders from your favorite local grocery stores. But then there was one, I think, about meals or something like that. Yeah, never mind. So like it can access basically data from other websites like to generate meal plans. Then it can, using those meal plans, create, okay, this is how much it will cost approximately. Maybe this is how much you will need to buy. And then it can use Wolfram Alpha, which is like also very interesting service to actually tell, okay, this chicken, it has that many proteins, it has that many calories, and like chicken soup, and then like about vegetables in general. And so just utilizing the fact that the model can generate the next word, it can look into the context by using new APIs, sort of, that it has access to. And I think this is the least that it has access to right now. Yeah.
So when you're asking things, it automatically uses those plugins?
I'm not sure about that. I think what you have to do is like tell it, yeah, go to Wolfram Alpha and do this and that. But maybe it can actually access them by itself. I've never worked with this. It like literally came out last week or something.
Okay.
Yeah, so there are a lot of resources already on how to actually write good prompts, good prompt engineering. And this is an article by OpenAI, and this is specifically for working with GPT-3. There are also public services that you can find, for example, on Reddit. People just upload a bunch of prompt engineering examples and everything that they find. And also one interesting example that people found was Dan. I'm not sure if you've heard of it or not. So I don't remember what it stands for.
Do anything now.
Yeah, do anything now, basically. So ChatGPT has inherent warnings or error that limitations that don't allow it to actually do anything malicious, like tell me how to make cocaine. Like it has the knowledge, but OpenAI is stopping it from doing that because, well, of course it can be sued, right? But then some very interesting people came up with ways to actually extract the knowledge. So you can say, oh, I want a bomb, but then it will say, no, I cannot do that. But then you can say, oh, it's for a science school science project, and then it will go, okay, and then just explain how do you make a bomb.
Awesome.
Yes, and it actually like provides really working examples, and that was a huge problem, and that OpenAI I think is still tackling, and like it's just people trying to go around the protection that it has.
Actually, I was talking to Ando a while ago
Mhm.
about how Ando does his tax for Ando Corp. And then I put this in ChatGPT, and it told me how like that I should stop doing tax fraud. So, so yeah, it's pretty smart. Do you know actually how that works? How OpenAI prevents ChatGPT from outputting anything?
I have a feeling it's manual. Only.
Yeah, I actually I don't know, but I would also assume it's very manual. Like they definitely did not retrain the whole model and like tell it, okay, I'm an OpenAI model and I'm not allowed to do that. It's probably something that they just output themselves.
Yeah, so what I heard is that there's actually quite a bit of business logic before your data actually enters the GPT model. I think also what I also read is that they actually hired people to feed it with good code examples and stuff like challenges to actually train it in a better way. But I'm not sure. But there's quite some manual stuff still involved in order to make this work.
And like, well, it also makes a lot of sense because like such a model is like it generated so much impact on our society. Literally, when it came out, it was like 5 million subscribers in like the first day or something. It's like the highest number of subscribers you can get to any service.
Highest adoption.
Yeah. And like it's always busy now, so like a lot of high schoolers just use it for their high school assignments, and just literally if you go to the university you can see every person has a ChatGPT on their side. So it's very revolutionary and has a lot of potential, good and bad, and yeah.
But you can't stop it, and it's with every technology, right? Good and bad.
True. And maybe something I want to conclude with, and maybe not something that many of you are interested in, however,
How to make a bomb.
how do you actually build one GPT model from scratch yourself? This is a very beautiful example that helped me understand like the GPT models themselves. It's made the tutorial is made by Andrei Karpathy, who was a director at director of AI at Tesla. He built the pipeline for computer vision for the Tesla auto drive models from scratch. So he's very, very influential, let's say, and he's a great teacher. And it's a, I think, 2-hour course. But if you do it actually, then you'll actually understand like the more in-depth parts about ChatGPT or like the GPT models themselves. And he makes a GPT model in the end, and then he trains it, and he trains it to generate Shakespearean text. So it's just generate a Shakespeare poem, and it is a Shakespearean poem. It doesn't make sense, but it is there. Yeah, I think that's it. Thank you for listening to my hot and spicy. I hope you gained some interesting examples or ways you can tackle or approach GPT models. Or maybe you came up with some new business idea that you'd like to start.
Bomb factory. Yeah. No, actually, now you mentioned the whole predicting the next word. I was thinking, like, oh, if you would analyze the way I speak, then you could probably have like if you train a model on my live speaking, and then it can probably predict with a good accuracy what my next word would be.
Yeah, possibly. Yeah, I'm actually quite interested in just trying to predict. Well, like I want to at some point download all my chat conversations and actually like create a model that kind of speaks like me. I tried to do so like a few years ago and like didn't really work. At some point, maybe I'll come back to that again. I'm just like interested in like how does it actually perform. Like
and then use that on an API or Tinder or something.
There was actually a guy who trained a model on Tinder likes and dislikes. So he like collected all his likes and dislikes, like 10,000 or 1,000 examples, and he trained a model to do it for it.
Then you need a model to talk as well.
I saw that someone actually had was using ChatGPT or something to reply to someone on Tinder. They only noticed after a couple of days of chatting. They were,
Then yeah, you don't need to do the effort. You can just go on the date.
yeah.
It's for us. It's the person that took out of the ball. That's your Tinder daytime.
No, I'm not sure. This was really cool, and I think the way you present such a topic is really well. It's really nice to listen to.
Thank you.
Yeah.
I have a question. So like the latest work that we discussed is ChatGPT 3, I think.
Yeah.
How big is the difference between ChatGPT 4 and ChatGPT 3 in terms of parameters, in terms of data size that it was trained on, stuff like this?
Oh, it's
Here we go.
Flexing with GPT-4, yes. Actually, I don't know about the number of parameters, but I've seen the comparison.
Better bomb.
That reminds me of those memes where it's like the first few seconds of the video just like a dog or something, and then the rest of the video is actually explaining how to make a bomb.
yeah.
Okay, so it's 175 billion indeed versus
A
I
lot.
don't even know how to pronounce it.
100,000 billion.
Yeah.
That's quite a lot.
But I'd say that I'm not sure about the performance differences. Many people say that it's a performance difference the same. However, GPT-4 has an interesting extension. First of all, it has a higher context size, so it's at 25,000. So you can literally put a whole documentation of Flutter and then tell it, okay, build me a Flutter app. Or maybe not even give it the documentation, just ask it for the Flutter app, and it will build you like the whole code base for that. Or I've seen examples of that at least.
This whole technology will also transform the way voice devices are currently made. Like the Google thing you gave us, if you compare that to what this one can do,
Yeah, definitely.
Will GPT-4 be included in ChatGPT and so on? Will they upgrade?
Yeah, it is already included. It's just like you have to pay money for it.
So if you pay for the pro suite, you get GPT-4.
Yeah, but also the cool
I'm
thing,
subscribing right now.
there are a few limitations of GPT-4, so it's very slow right now. They still haven't figured out how to improve the speed, because that's a huge amount of parameters that you should have to work with. And I think not everyone can actually work with the GPT-4 right now, but you can access it through OpenAI Pro subscription, whatever.
or we can locally host the model under the couch.
I don't think so. I'm afraid not.
Oh, we have a lot of computers there.
No, this is not a lot of computers.
An interesting thing about GPT-4 is that it can actually process images, and it can have visual input now. So you can give it a layout that you could draw by hand, and then tell it, okay, from this layout, build me the whole application or a website, and then it will actually do so.
Do you know how the image inputs corresponds to like number of tokens that it consumes?
I have a very interesting suspicion, and I think it's also very natural for OpenAI to do so, like especially the image part, because a few years before, DALL-E.
Yeah.
Yes, I would assume everyone knows DALL-E. So for DALL-E, they before they made it, they trained another model called Clip, which I mentioned also. So the Clip is actually connecting text with images. So if you want how to understand it, is that it's basically like a map, a function that takes a piece of text and an image, and well, if the text corresponds to the image, then it maps to like one point. And well, it is good at basically putting the images and text into one latent space. And I would assume the GPT model, the GPT-4 model, uses a model like this or something similar to basically encode the text that it has, or encode the images that it gets into tokens which are corresponding to also some text in some space. So it basically can also read images. Yeah.
And if you go to the GPT-4 thing that is not on ChatGPT, does that actually allow you to build bombs?
I would think I would get banned.
What is about this fascination with
I know. I'm just fascinated by how OpenAI managed to build in this this barrier on what is an output. Like I have the suspicion that there's probably trained another model that determines whether something is malicious or not, and then they use that.
They use a VPN for these froms.
What do you mean?
No, just kidding. Oh, build stuff. Okay.
I'm gonna ask a bomb later.
So this is pretty fast. The video that starts with the cats and then it's an explanation.
Yes.
It's a mask.
Now, are you paying for GPT subscription?
No, I'm a beta tester.
Okay.
Wow.
Fancy, right?
That's like the fancy word of saying you paid for it, but then not.
You don't pay per token, huh? Oh
No, I think I have a limit, but like, I have to also give reviews of how it works and where it could be improved. But I don't see they give us feedback. I just don't.
Stop.
Also, the cool thing is in this dashboard specifically, you can toggle. You can literally write a message as if you were the assistant, or you could present yourself as a user or something. So then.
This is not 25,000 words, or did you set a limit on the right somewhere?
No, well, like, yeah,
there's a maximum length there.
yeah, it has
yeah.
a maximum length.
Yeah.
Because like you don't want the model to waste all of your tokens into like one go. It's like if it actually uses all the 25,000, then you will not be able to add anything to it because it will have to cut down somewhere. It's like the window size it sees it's only like 25,000.
I noticed with experimenting that after you go over that context limit, it starts hallucinating a lot and just making up stuff as it goes.
Mm-hmm.
But still with the very confident nose that it knows what's talking about.
Also, I'm not sure if you explained this while I was away, but you have the temperature and the P parameters on the right.
Yeah.
How do those work?
Okay. I don't have a concise and clear explanation of how they work, but I have an analogy that could probably help you. So imagine a person with a fever. If the person is with a fever, then, well, they just say gibberish. They say nonsensical stuff and their brain is just not working.
UI designs.
Exactly.
What?
But if you set a low temperature to the model, it's like a person who has a just low temperature. So they're very like, I'm weak, I'm kind of dull-ish. So they're like very straightforward, very factual, short answer and stuff like that. So that's how you can kind of wiggle inside of the space of temperature, like what it does. The default parameter for temperature is like 70%. Yeah, sometimes I set it to higher if you want to like have like crazy outputs, like I don't know, make a story. So if you want to make a story, then you probably want like a creative idea. So you set a higher temperature, but not one problem. If you want something more factual, maybe I would just decrease it.
But so this kind of seems something that affects the entire model. But I also highly doubt that they can just run another instance of the model with different temperature.
Yes.
So
So this is the cool thing about the GPT models. The GPT model, it predicts the next word, but it doesn't just predict the next word. It predicts the whole probability distribution for all the words that could be next. And actually, this is a nice point because we could go into how do you check if the model or text was written by a GPT model. But yeah, basically it generates a distribution for like, okay, this probability for this token is like this many percent for this token, and so on. And then it randomly samples from the space. And well, the temperature and top P, they define the how do you sample from that space. I don't know about top P. I think, oh yeah, controls diversity via. But okay, so it's top P is kind of like it's gonna how many of the options it's gonna consider. So kind of it's like the probability of choosing the option, like the probably one of the highest options. So if you have like a top P of 1, it's don't take my word for it, but I would assume that it's
Like a whole range.
no, it's of the across the top probabilities probably. And then if we set it to 0.5, it's the whole range. Can I speak regenerate? I don't know how it affects also the models, the performance of like text generate.
I saw an example with this, like I think it was similar to the example you showed with like logic solving, where then it was for ChatGPT like a 25% chance on giving the wrong answer, and I think that's like fully in line with what you mentioned on the distribution that then just rolled the dice differently and came on the wrong answer.
Yeah, exactly. That's why you also get different responses every time you ask it, because yeah, we can ask it again about researchable.
Have you heard of prompt engineering? Yes.
This text data, it was also generated by Chat.
In part, yes. Oh, Mansoor just proved that. Oh,
So what does this mean? I'm also not sure what about what I'm gonna say, but I feel like that's how it's made. So this basically tells it's a probability heat map of like having this word sort of like written by the GPT model. So when it was sampling from the distribution, this is like basically tells the probability of having the word have. So it's like probability of 17.
Oh wow.
Then you get a probability of 16 for use, and blah blah blah. And technically could have chosen one of those words, but it chose have. And same goes for all the other words that are in here. And well, now you can basically every time now when you want to check if the text was written by a GPT model, well, you have to have the access to the model itself. But like when you have access, that the rest is super easy, because like you generate, okay, what should come next, and then you compare the probability distribution with the word you have actually. And well, I would assume you could use some smart statistics to actually predict what is the probability of a sample being generated from the probability distribution that the GPT model supports. And
that's statistics 101, right? To see if the distribution is the same as a different distribution.
exactly.
but it's in Google's well, advantage to run a check on this on the whole internet, right?
Yeah.
I have some gripes with this detection of whether something or not is written by
You're saying
ChatGPT.
gripes? What does it mean?
Complaints.
Complaints, yes. I also have
Well,
complaints.
so I had a ChatGPT. I said write a story, just to come up with a story, and then I copy paste that in the ChatGPT detector thing. I said 99% sure it was written by an AI, and then I went back to ChatGPT and I said write a story, but include some specific landmarks from Groningen. I took that story, which had something about two people meeting at the Martini Toren and stuff like that, which is like if you just go through your percentages, Martini Toren will never So when I pasted that in there, it's a 0% chance that this story was generated by ChatGPT, but it was. I just gave it a slightly different prompt, like a very specific prompt, which would incur words that normally don't happen in the model.
Indeed, that's also what I thought about. Like, you can technically, well, this assumption is made like we look at this distribution just because we assume that we have the whatever was previously, and we also assume that whatever was in the text is actually not altered by the human themselves. So just like some little alterings by the human, or having the model just not giving the prompt that you gave to the model initially, it poses like a much difficult challenge to actually finding out if the text was written by the GPT model or not.
So it's very easy to get around. Just say, mention this specific events in my local town, and no one will ever figure out.
For your thesis marks.
Yeah.
Just change the first.
How to plagiarize and get away with it.
Yeah.
This is very interesting prompt engineering, probably, that people look into, because like high schoolers probably use it a lot to get away with stuff. I use it also to get away with stuff.
Ask it to write a text which seems like it has not been generated by an AI, so that it doesn't use the I don't know
Acid typo. Just a single typo. Do you have any idea how the training for something like this was done in parallel?
What do you mean?
Well, they trained this on a huge cluster.
Yes.
Which means that the model itself probably consists of several components.
Yes.
But then, if you train all of those components separately, you don't have a full cycle from, okay, this is the front and this is what the output is. Is that correct? You cannot do that if you split up your model.
Okay, so yes, so I think this also covers into like how do you even parallelize training of machine learning networks. And well, you actually don't like, as far as I know, you don't parallelize the one example that is going through the network. You parallelize the examples themselves. So you have multiple examples going in parallel, and they go through the whole model. And then this is done in parallel, so you can have like 19, 20, 100 parallel examples. And then the computer aggregates all of those examples, the performance of those examples, and propagates the update back. So,
but that's like exactly the thing. How do you aggregate?
Well,
examples?
First of all, you do like 16 examples. You get the results on the 16 examples, and then you literally, because well, you have like a topologically same neural network every time you train it. You can also aggregate it by the topology of the network. So you add or average the weight updates that there are. So for example, if some example says update this weight by 50% and some example says update it or decrease it by 60%, then you literally add these things, average them out, and yeah.
Oh yeah, I see.
I think that's the whole principle behind the stochastic gradient descent. I think.
It's cool that this stuff still uses like this very old way of training a model. I would have expected something very fancy.
Actually, like a lot of people I think assume that GPT-3 model would be like super fancy, it's like some new methodology, but like it's nothing else. It just uses the same techniques, just bigger model, and what they actually observe is like the emergent behavior that you actually get from that.
And so then you can also train it in an online fashion, I guess. So you can update the existing model that you already have. Right?
Yeah, I think so. I think that's possibly what they do with Copilot, maybe, because like they collect all the data, all the examples, if you agreed upon that, and maybe it's like not online, but like they aggregate all of those examples and then like in batches train the thing.
So yeah, cool. All right. I don't know the floor. Thanks, Mansoor, for this presentation. I think that concludes Hot and Spicy.
And really cool that
It
your
was
friend
really nice.
made the tool from the API. So,
Thanks everyone for attending online as well.
Make sure to check out.
Cool example.
Are you sponsored by Center?
No, I'm not.
Okay.